Hello students, how are you all? I am Gurmeet Singh and welcome you to CREATA classes and also welcome to our complete series on trigonometry for class 10 student. In this lecture or in this series, we will cover all these lectures using the power of visualization. You will love our unique way of teaching. Apart from this lecture, we are also having a complete PDF of the formula and concept list. Check out the link in the description. And we also have the cues related to the various trigonometric questions. To check the level of your understanding of the concept, check the link in the description. And especially in this lecture, we will cover the trigonometric ratios of specific angles. So without taking any further time, let's start with this lecture. Best of luck. In the previous lecture, we have studied about the trigonometric ratios. These are the 6 trigonometric ratios that we have covered: sine, cos, tan, cosec, sec and cot. And theta is a trigonometric angle. Sin theta is a trigonometric ratio and theta is a trigonometric angle. And we have also studied that this theta is angle. For example, sin theta can be sin 30 degree, it can be sin 60 degree, sin 40, sin 10, anything. Theta is the angle. Further, we have also studied that value of the trigonometric ratios for the angle is fixed. That is, sine 30 degree will have some value, cos 30 degree will have some value, sine 10 degree will have some value, sec 20 degree will have some value. So the values of trigonometric ratios for the angles are fixed. Let's understand this value of the trigonometric ratio concept in some detail. For example, we are having a triangle with trigonometric angle as 30 degree. Here this is perpendicular and this is hypotenuse. The side opposite to trigonometric angle is perpendicular and the side opposite to 90 degree angle is the hypotenuse. For example, perpendicular is 1 and hypotenuse for this triangle is 2 cm. Sin 30 degree will be perpendicular over hypotenuse. Perpendicular is 1 cm, hypotenuse is 2 cm. So the value of sin 30 degree will be 1 by 2. Got it? The value of sin 30 degree is 1 by 2, that is 0.5, and this value is fixed. You can change the triangle, you can increase the size, decrease the size. If the trigonometric angle for the triangle is 30 degree, then sin 30 degree will be 1 by 2. That is, the ratio of perpendicular upon hypotenuse will be equal to 1 by 2, whatever triangle you take. For example, if we take second triangle in which the trigonometric angle is 30 degree and if the perpendicular is 5 cm, then the hypotenuse will be 10 cm. Sin 30 degree is perpendicular upon hypotenuse, 5 is the perpendicular, 10 is the hypotenuse. 5 upon 10, it will be 1 by 2. So sin 30 degree we got as 1 by 2. This sin 30 degree value is fixed. You can do a small experiment. Just draw a random triangle with angle as 30 degree. Just calculate the perpendicular and also the hypotenuse. The ratio of perpendicular and hypotenuse, it will be 0.5. That is 1 by 2. Just try this small experiment. These small experiments are really helpful in developing the building blocks. So my advice, just pause this video and do this small experiment. Okay. So we understood that the values of the trigonometric ratios are fixed. That is, the trigonometric ratios for the angles will have some value. And in this lecture, we will calculate those values. We will not go for all the angles, we will take only some specific angles and we will calculate the value of trigonometric ratios. These angles are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. We will calculate the value of trigonometric ratios, all the 6 trigonometric ratios for this 5 angle. It means we will calculate sin 0 degree, sin 30, sin 45, sin 60 and sin 90. Similarly for the cos, all the 5 values, and for tan, cosec, sec and cot. So all these values we will calculate in this chapter. This is a long table, but do not worry about that. You don't have to stress about memorizing it. At the end of the lecture, I will share some quick techniques to remember the complete table very easy without any effort. It will be on your fingertips. So do not be worried about the length of the table. You will be able to easily remember it. So stay tuned and enjoy the learning journey. Okay, let's move further. So we will take angle one by one. Firstly, we will take 45 degree, then we will go with 30 and 60 degree, then we will go with 0 and 90 degree. First, let's take the 45 degree. In this 45 degree, we will calculate the value of all the 6 trigonometric ratios. Let's take a triangle ABC, which is right angle at angle B. And for this triangle ABC, angle A and angle C are 45 degree. Here angle A and angle C both are equal to 45 degree, that is both are equal to each other. And we know the property of the triangle, that is the sides opposite to equal angles are also equal to each other. It means angle A and C are equal, that is AB and BC will be equal to each other. These two angles are equal, so these two opposite sides will be equal to each other. This is the property of the triangle. Let's assume AB and BC both as equal to A. So we got the two sides of the triangle. Let's find the third side, that is AC. We can use the Pythagoras theorem. AC square is equal to AB square plus BC square. So we got AC square is equal to 2A square. On solving, we got AC as A root 2. We got all the three sides of this triangle. Let's identify what is perpendicular, what is base, and what is hypotenuse. Firstly, perpendicular. Here angle A we are assuming as a trigonometric angle, which is 45 degree. So the side opposite to trigonometric angle is the perpendicular. So BC is the perpendicular. Got it? BC is the perpendicular. Further, hypotenuse is the side which is opposite to 90 degree angle. Angle B is 90 degree angle, so the side AC will be the hypotenuse for this triangle. And the third remaining side AB is the base for this triangle. So we got all the three trigonometric sides. Now we can easily find any of the trigonometric ratios. Let's find sine 45 degree. Here we have taken angle as 45 degree because our trigonometric angle is angle A, which is 45 degree. Okay. Sine we know it is perpendicular over hypotenuse. Perpendicular is BC and hypotenuse is AC, which is A upon A root 2. So we got sine 45 degree as 1 upon root 2. Got it? We got our first trigonometric ratio value, that is sine 45 degree is 1 upon root 2. Further, let's find cos 45. Cos we know it is base upon hypotenuse. Base is AB and hypotenuse is AC. So it will be A upon A root 2, which is 1 upon root 2. So we got the value of cos 45 as also equal to 1 upon root 2. Got it? Further, let's find tan 45 degree. We are having two approaches to find the value of tan 45 degree. Firstly, using the formula, that is perpendicular upon base. Perpendicular is BC, base is AB, which is A upon A, that is 1. Tan 45 degree value is 1. Got it? The second approach to find the value of tan, that is tan 45 degree is equal to sine upon cos, that is sine 45 degree upon cos 45 degree. And we have already calculated both the values, 1 by root 2 upon 1 by root 2, that is 1. So we got the value of tan 45 degree as 1. Okay, we have got the value of sine 45 degree, cos 45 degree and tan 45 degree. Now let's calculate the three remaining trigonometric ratios, that is cosec 45, sec 45 and cot 45. And we know cosec is the reciprocal of sine, sec is the reciprocal of cos and cot is the reciprocal of tan. Sine 45 degree is 1 by root 2, so cosec 45 degree will be root 2. Cos 45 degree is 1 by root 2, so sec 45 degree will be root 2. Tan 45 degree is 1, so cot 45 degree will also be equal to 1. Got it? We have calculated the trigonometric ratios for 45 degree angle. Let's put all these 6 values in the trigonometric ratio table. We have done for 45 degree angle. If you observe here, sine 45 degree and cos 45 degree both are equal to each other. This is the observation that we got from this table. Do not worry about cosec, sec and cot. These are just a reciprocal of sine, cos and tan. Just focus on sine, cos and tan. You will automatically get cosec, sec and cot. So for the time being, we will just ignore cosec, sec and cot. We will only focus on sine, cos and tan. Here sine 45 degree and cos 45 degree both are equal to each other. This is the observation. You should note it down. Okay. No need to note it down, just go to the description and download the PDF of the complete formula and concept list. There you will get all the concept. This observation we will use at the end of this chapter. Okay. So we have done with 45-degree angle. Let's move to next angle, that is 30-degree and 60-degree. Both angles we will take simultaneously. Let's see. For that, let's take a equilateral triangle ABC. This is the triangle ABC, equilateral triangle. All the three sides and all the three angles are equal to each other. All the three angles are equal. That is, all the three angles are 60 degree. 60, 60, 60. Further, let's draw AD, which is perpendicular to the side BC. This AD is perpendicular to BC, forming the 90-degree angle at angle D. Basically, this AD is dividing the complete triangle ABC into two triangles. We got the triangle ADB and triangle ADC. Both of these triangles are right angle triangle at angle D. So we got two right angle triangle. Right angle triangle, it means we can apply the trigonometric ratios and also the Pythagoras theorem. That is the importance of a right angle triangle. That's why we love the right angle triangles, because we can easily apply the Pythagoras and the trigonometric ratio, which we cannot do easily in the other type of triangles. Okay, that's why we have drawn AD, which is perpendicular to BC, so that we can get the right angle triangles. Further, can we say both of these triangles are congruent to each other? Congruent means the two triangles are exactly copy paste of each other. Can we say so? Let's check it out. Here both the triangle are right angle triangle, that is angle D in both the triangles are equal to each other. Further, AD is the common side, so AD will be equal to each other. And AB and AC, that is the hypotenuse for both the triangles, are also equal to each other. Why? Because in the starting we have taken the triangle ABC as an equilateral triangle, and in the equilateral triangle all the sides are equal. So AB and AC will be equal to each other. So by RHS criteria, we can say both the triangles are congruent to each other. RHS, right angle, hypotenuse, side. Here both are right angle triangle, hypotenuse are also equal, and one of the side, that is AD, is also equal. So we can say both the triangles are congruent to each other. And once we got two triangles as congruent, by CPCT we can say the corresponding angles and corresponding sides of both the triangles will be equal to each other. Here BD and DC, these two sides will be equal to each other by CPCT, corresponding part of congruent triangle CPCT. So BD is equal to DC. Further, we can say these two angles will also be equal to each other. Both are corresponding angle. Angle BAD is equal to angle CAD by CPCT. The complete angle is 60 degree. So can we say both of this angle will be equal to 30 degree? Complete angle is 60, both angle are equal, so both angle will be equal to 30 degree each. So if you observe the triangle ABD, we got all the three angles. This angle is 30 degree, this angle is 60, and this is 90. So we can apply the trigonometric ratio in this triangle. Only the missing dimension is the sides of this triangle. So let's go for the sides of this triangle. The complete triangle ABC is an equilateral triangle. That is, all the three sides are equal. Let's assume the sides of this equilateral triangle as 2A, twice of A. All the three sides are equal, so all will be equal to 2A. Got it? Further, we have just got BD and DC. Both of these line segments are equal. That is, D is the midpoint. The complete length BC is 2A. So can we say BD and DC both will be equal to A? Got it? For the time being, let's remove the triangle ADC and only retain the triangle ADB. Okay, we have got only one triangle ADB, which is having the angle as 60 degree and 30 degree, for which we have to find the trigonometric ratios. AB is 2A and BD is A. Two sides we know. We can easily calculate the third side using the Pythagoras theorem. This is a right angle triangle, so we can apply the Pythagoras, which is AB square is equal to BD square plus AD square. Let's put the value. On solving, we got AD square is equal to 3A square. Therefore, AD is equal to A root 3. We got all the three sides of this triangle. Next step before applying the trigonometric ratio is to mark the trigonometric side, that is, which is base, which is hypotenuse, and which is perpendicular. For that, we have to identify the trigonometric angle. Here we are having two angles, 30 degree and 60 degree. We will take two cases. In the first case, we will take angle A as 30 degree. and we will calculate the trigonometric ratio, that is sin 30, cos 30, tan 30 and all the other trigonometric ratio. In the second case, we will take angle 60 degree as the trigonometric angle. Then we will calculate sin 60, cos 60, tan 60 and all the other trigonometric ratio. This way we will get the value of all the trigonometric ratios for 30 degree as well as 60 degree. Firstly, let's check the case where our trigonometric angle is 30 degree. Let's find the trigonometric sides. Here BD will be the perpendicular, that is the side opposite to trigonometric angle. AB will be the hypotenuse opposite to 90 degree angle, and the third remaining side is the base, that is AD. Got it? So we got all the three trigonometric sides with respect to trigonometric angle 30 degree. Firstly, let's find sin 30 degree, which is perpendicular upon hypotenuse. Perpendicular is BD and hypotenuse is AB. So we got sin 30 degree as A upon 2A, that is 1 by 2. Sin 30 degree we got as 1 by 2. If you remember, in the starting of the lecture we have taken an example in which we have taken a triangle with angle as 30 degree. There we have seen that sin 30 degree is 1 by 2. So yes, sin 30 degree is 1 by 2. Okay. Next, find cos 30 degree, which is base upon hypotenuse, which is AD upon AB. AD is A root 3, AB is twice of A. So we got cos 30 degree as root 3 by 2. Got it? We got sin and cos. Let's find tan, which is perpendicular upon base. Perpendicular is BD, base is AD. So we got A upon A root 3, which is 1 upon root 3. Tan 30 degree is 1 upon root 3. Okay. Once we got sin, cos and tan, we can easily find cosec, sec and cot as the reciprocal of sin, cos and tan. Sin 30 degree is 1 by 2, so cosec 30 degree will be equal to 2. Cos 30 degree is root 3 by 2, so sec 30 degree will be 2 upon root 3. Tan 30 degree is 1 upon root 3, so cot 30 degree will be root 3. So we got all the 6 trigonometric ratios for 30 degree angle. Okay, let's take down 60 degree angle. This is a triangle where the trigonometric ratio is 60 degree angle. Firstly, let's find the trigonometric sides. Here AD will be the perpendicular, which is the side opposite to trigonometric angle. So AD is a perpendicular. AB is the hypotenuse, which is opposite to 90 degree angle. And the third remaining side BD is the base for this triangle with respect to 60 degree angle. Got it? We got the trigonometric sides. Let's find the trigonometric ratio. Sin 60 degree, which is perpendicular upon hypotenuse, that is AD upon AB, which is A root 3 upon 2A. So we got sin 60 degree is equal to root 3 upon 2. Got it? Let's go for cos 60 degree, which is base upon hypotenuse. Base is BD, hypotenuse is AB, which is A upon 2A, that is 1 by 2. Let's go for tan 60 degree, which is perpendicular upon base, that is AD upon BD, A root 3 upon A. So tan 60 degree is root 3. We got sin 60, cos 60 and tan 60. Next step is cosec 60, sec 60 and cot 60, which will be reciprocal of sin 60, cos 60 and tan 60 respectively. Sin 60 is root 3 by 2, cosec 60 will be 2 upon root 3, cos 60 is 1 by 2, sec 60 degree will be 2, tan 60 degree is root 3, cot 60 degree will be 1 upon root 3. So we got the trigonometric ratios for 30 degree and 60 degree. Let's put this value in the trigonometric table. Okay, we got the trigonometric ratios for 45 degree, 30 degree and 60 degree. Here if you observe 30 degree and 60 degree values, here sin 30 and cos 60 both are equal to each other, that is 1 by 2. Sin 60 and cos 30 both are equal to root 3 by 2. So this is the observation that you should note. Sin 30 and cos 60 both are equal. Cos 30 and sin 60 both are equal. This we will use at the end of the lecture. Okay. So we have done with 30 degree and 60 degree. Let's move to next and the last trigonometric ratio, 0 degree and 90 degree. We will go one by one. Firstly, let's take 0 degree. So we have to draw a triangle in which the trigonometric angle is 0 degree. Are you able to draw a triangle in which angle theta or trigonometric angle is 0 degree? Let's see. First, let's take a triangle ABC where angle A is the trigonometric angle and angle B is the 90-degree angle. Here we have to make this angle A, that is trigonometric angle, as 0 degree. Before that, let's identify the trigonometric sides for this triangle. Here AC is the hypotenuse as it is opposite to 90-degree angle. BC is the perpendicular as it is opposite to trigonometric angle A, and AB is the base for this triangle. Okay. We have to make this angle A as 0 degree. Let's do so. Here angle A is having certain value. Let's decrease this value. We are decreasing the angle A till it reaches 0 degree. So our triangle is shrinking. The side BC is decreasing. Let's do it furthermore till it reaches 0 degree. So here we got a straight line AB. B and C both are coinciding with each other. The triangle has been converted to a straight line. But we got our angle A as 0 degree. Got it? We have converted a triangle with trigonometric angle as angle A into a triangle which is having angle A as 0 degree or trigonometric angle as 0 degree. That is, we got a straight line. Do not worry, this is the procedure to approach the trigonometric ratios for 0 degree. In the first figure, in the triangle ABC, we are having the perpendicular as BC, and in the end result, BC is equal to 0. B and C are overlapping with each other, so BC is equal to 0, that is perpendicular is equal to 0. AB is the base and AC is the hypotenuse. And in the end result, that is in the straight line, AB and BC both are equal to each other. That is, base and hypotenuse for this triangle are equal to each other. So let's find the trigonometric ratios. Firstly, sine 0 degree, which is perpendicular upon hypotenuse. Here perpendicular is 0 and hypotenuse is AC. So we got sine 0 degree is equal to 0 upon AC. It will be equal to 0. So we got the value of sine 0 degree as 0. Got it? This is the interesting way. So we got sine 0 degree is 0. Further, let's find cos, that is cos 0 degree, which is base upon hypotenuse. Base is AB and hypotenuse is AC, and we got that AB and AC both are equal to each other. So we got cos 0 degree is equal to 1. Okay, we got sine 0 degree is 0 and cos 0 degree as 1. Let's find tan 0 degree. Tan is basically sine upon cos. Tan 0 degree is equal to sine 0 degree upon cos 0 degree. Sine 0 is 0 and cos 0 is 1. So we got tan 0 degree as equal to 0. Okay. Sine 0 degree is 0, cos 0 degree is 1, tan 0 degree is 0. Once we got sine, cos and tan, we can easily find cosec, sec and cot using the reciprocal method. So cosec 0 degree will be equal to 1 upon 0. What it will be? It will not be 0. It is not defined. 1 upon 0 is not defined. What you should multiply with 0 to get the number as 1? It is not defined. That is 1 upon 0 is equal to not defined. Note that this is a common point of mistakes done by the students. 1 upon 0 is not defined. Okay. Let's find sec 0 degree, that is 1 upon cos 0 degree. 1 upon 1, that is 1. Let's go for cot 0 degree, which is again 1 upon 0, that is not defined. So we got all the 6 trigonometric ratios for 0 degree. Let's put it into the trigonometric ratio table. Let's come back and let's find the trigonometric ratio for 90 degree. Okay. Here basically we have to draw a right angle triangle in which the trigonometric angle is 90 degree angle. Let's take a triangle ABC. Angle B is 90 degree. That is, it is a right angle triangle. And here angle A is a trigonometric angle. Firstly, let's find the trigonometric sides. Here AC is the hypotenuse which is opposite to 90 degree angle. BC is the perpendicular which is opposite to our trigonometric angle A. The third remaining side AB is the base. Okay. and we have to make this angle A as equal to 90 degree because our trigonometric angle in this case is 90 degree angle. How we will do that? We will increase this angle till it reach 90 degree. Let's see how we do so. Let's increase this angle. On increasing the angle, AB is reducing. Let's keep on increasing the angle till it reach 90 degree. So here the angle A is 90 degree, but again our triangle has been changed to a straight line. Point A and point B are overlapping. Here AB has been turned to 0. AB is the base, so we got base for this triangle with respect to trigonometric angle A is 0. Here hypotenuse and perpendicular both are equal to each other. Hypotenuse is AC and perpendicular is BC, so AC is equal to BC. So this is the case. Let's find the trigonometric ratios for 90 degree angle. Firstly, sine 90 degree, which is perpendicular upon hypotenuse. Here perpendicular and hypotenuse both are equal to each other. So we got sine 90 degree is equal to 1. Okay. Sine 90 degree we got as 1. Let's find cos 90 degree, which is base upon hypotenuse. Here base for this triangle has been turned out to 0 units. So we got cos 90 degree as 0 upon hypotenuse, which is 0. Sin 90 degree we got as 1, cos 90 degree we got as 0. Let's find tan 90 degree, which is sin 90 degree upon cos 90 degree. That is 1 upon 0, which is not defined. Okay, do not be confused. 1 upon 0, it is not defined. So we got sine, cos and tan. Let's find cosec, sec and cot using the reciprocal technique. Cosec 90 degree will be equal to 1. Sec 90 degree will be equal to 1 upon 0. That is not defined. And cot 90 degree will be equal to 1 upon not defined. That is equal to 0. How it is 0? Basically tan 90 degree is equal to 1 upon 0 and cot 90 degree will be the reciprocal, that is 0 upon 1. So 0 upon 1 is equal to 0. So we got cot 90 degree is equal to 0. So we got all the 6 trigonometric ratios for 90 degree. Let's put it into the table. So we have finally completed the trigonometric ratio table. It includes the value of the 6 trigonometric ratios for some specific angles, which are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. And one important thing, this table you have to remember. Don't worry, don't stress out. I will share some techniques how to remember the table in very easy way. After a few minutes, this table will be on your fingertips. Before proceeding, I want you to pause the video and review this table in very detail. Just observe the different values in the each section. It will help you understand the table in more detail. Okay? Just pause the video and take some time. So you have observed this table. Why I have told you to observe the table? So that you can remember some of the value and you can understand some of the linking between different trigonometric ratios. Let's see. The technique is that you only have to remember the trigonometric ratios of sine theta. Only the first line. If you are able to do so, the rest of the table will come automatically. Let's see. You only have to remember like 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. These 5 values only you have to remember. The values of cos theta is in the reverse order. What I mean to say is that the value of sine is 0, 1 by 2, 1 by root 2, root 3 by 2 and 1, and the values of cos are in the opposite order. That is 0, 1 by 2, 1 by root 2, root 3 by 2 and 1 in the opposite order. Once you got the value of sine theta, just put the value of cos theta in the opposite or the reverse order. That is from right to left hand side. Sine is from left to right, cos is from right to left. Okay, so once you remember the sine, you will automatically got the cos in the reverse order. And once you got sine and cos, you know the formula of tan, that is sine upon cos. Just divide sine by cos, you will get the value of tan. Like here 0 upon 1 it is 0, 1 by 2 upon root 3 by 2 it is 1 by root 3, 1 by root 2 upon 1 by root 2 it is 1, root 3 by 2 upon 1 by 2 it is root 3, and 1 by 0 it is not defined. Got it? Once you got sine theta and cos theta, just take this line as a divide line and do the division, and you will get the value of tan theta. And once you got sine, cos and tan, just do the reciprocal, you will get cosec, sec and cot. So we will not worry about cosec, sec and cot. Once you get sine, just do the reciprocal, you will get cosec. Once you got cos, just do the reciprocal, you will get sec. Once you got tan, just do the reciprocal, you will get cot. So just remembering the value of sine theta will complete the full table. Got it? So this is a small technique that you can use to remember this table. So for experimental purpose, we will take a blank table and we will fill this blank table. The same thing you have to do at the starting of the examination. It will hardly take 30 seconds. Within 30 seconds, you can complete this table. Okay. So the first step, just write down the value of sine theta that you have remembered, like 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Cos theta, the value will be in the reverse order, right to left. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Tan theta, it is sine upon cos, 0 upon 1 it is 0, 1 by 2 upon root 3 by 2 it is 1 by root 3, 1 by root 2 upon 1 by root 2 it is 1, root 3 by 2 upon 1 by 2 it is root 3, 1 upon 0 it is not defined. Cosec, it is the reciprocal of sine, just do the reciprocal of all these 5 values. Similarly, sec is the reciprocal of cos, let's do the reciprocal of these 5 values. Lastly, cot is the reciprocal of tan. Let's do the reciprocal of these 5 values. So we got the complete table. Just remember that at the cot 90 degree, the reciprocal of not defined you have to take as 0. Don't get confused in this. So we have completed this table. My advice to you, just draw a blank table on your notebook and try to fill the table without looking at the sheet. One more thing, go to the download section, download the formula and the concept list. There you will get the printable format of this table. Just print the table and keep it on your notes, on your table, on your wall, wherever you feel comfortable. And frequently revise this trigonometric table. Within a few times, this table will be on your fingertips. Okay. So students, that's it for this lecture. Hope you have enjoyed our creative way of teaching. If you have enjoyed this lecture, if you have gained anything out of this lecture, please like, share and subscribe to our YouTube channel, that is CREATA CLASSES. We add creativity to the learning. And note that this lecture is part of the complete series on trigonometry for class 10 student. The link to the other lectures are given in the description. Check it out. And apart from this, also check out the PDF of the complete formula and concept list and also the quiz related to trigonometric questions, where you can check the understanding of the trigonometry and the questions. So that's it for this lecture. Bye for now. Best of luck for the exam you're preparing for and have a great day. Bye.